Okay, we're going to do surface area and volume of spheres in this video. So we're going to hit both of those at the same time. There's a formula for each of them. Pretty simple to use. We're going to be using pi. Keep in mind we used pi when we did circles. And if you think about a sphere, it's almost kind of like a three-dimensional version of a circle. So still going to have pi in it. I'm going to kind of explain where the formulas come from, but to prove to you that these formulas work, it's a lot easier if you use calculus, and obviously you're in a geometry class, you haven't taken calculus yet, so I'm not going to try to prove to you that way. All right, so first one is our surface area formula. Now for surface area, I'm just going to abbreviate it as SA. All right, so that's our surface area formula, just 4 pi r squared. All right, kind of similar to the area of a circle. Area of a circle is pi r squared. So this just has that 4 out front. I'm going to kind of show you why that works. This is not a proof by any stretch of the imagination, but if you look at a baseball or a softball, I don't know if you've ever had the chance to like take one of those apart. They're kind of cool when you take them apart. But this is kind of what a baseball or a softball looks like when you take it apart. Okay, I found this image, printed it off. So there's a core here, and this really is a lot more complicated. There's a rubber ball inside, and they wrap a bunch of string around it over and over and over and over again. But this is the two leather pieces that they then stitch together. So kind of these figure 8 type things. But basically, you kind of have a circle here. You kind of have a circle here. You kind of have a circle here, and you kind of have a circle here. Now, not quite a circle because there's a little bit missing here, and it's off a little bit here, and this stuff kind of fills in those missing pieces and so on. But you can kind of see how it looks like 4 circles. That's what I want you to get you to understand visually. Say, okay, now if I wrap that, so then what they do, I don't know if you'll be able to picture this, they take the one piece and they fold it up this way. They take this piece and they fold it this way and then turn it, and then they kind of stitch it together like that. And that's kind of how you get that spherical kind of shape. So they take the two, all right, fold them up, fold it down, spin this one, and sink it in together like that. And that's how they get that spherical shape. So that 4 circles that you can kind of see there, they make up the outer part of the sphere, what we call the surface area. Okay? Now, for volume, that's a little more complicated. Okay? Volume is 4/3 pi r cubed, or you can write as 4 pi r cubed over 3. Same exact idea. Sometimes this one is easier to use. This is how we usually say it, 4/3 pi r cubed. Same thing, 4/3 pi r cubed. Okay? So those are the formulas we're going to be using today as we go through this video. I'm going to show you how to apply them, and then if I give you the surface area of the volume, how we kind of work backwards to find the radius. Okay, so let's start with a sphere. Now to draw a sphere, and you don't necessarily have to draw these most of the time, if on the worksheet I give you they'll be drawn for you, but what we do is we kind of draw a circle, and then we kind of draw from the middle, we kind of come this way, and then on the back side we kind of make this little dotted line to make it kind of look three-dimensional. Okay, so that's kind of how we draw a sphere. And then for the radius, we would just start right in the middle here, and we'd come out over here to the edge, and we'd say, you know, that's R. Okay? So that's kind of how you draw a sphere. That's how you'll see them drawn. If it went all the way across, that would be the diameter. All right, and we can always cut the diameter in half to find the radius, just like we did for a circle. So I'm going to fill a number in here, and we're going to find the surface area, and we're going to find the volume. So I'll start with a nice, easy number. Let's do like 10. Okay? So if that distance right there is 10, and I want you to find the surface area and the volume, and let me give it a label of inches so that we can give our answer for surface area and volume a proper label. All we do now is fill in our formulas. So surface area equals 4 pi 10 squared. Okay? We must do powers first. So this would be 4 pi 100. Order of multiplication does not matter, so we can multiply and get 400 pi. And then we put a label on area. Even though it's surface area, three-dimensional objects have surface area, the area of all of their surfaces added together. All right, it's still an area concept, so it's still inches squared. All right, for volume, 4 pi r cubed over 3. So 4 pi 10 cubed over 3. Now, on your calculator, you can do 10 cubed. Okay, so let me get a calculator out here. show it to you. So if I want to type in 10, I would just type in 10. Then there's this button right here on the calculator, that little kind of upside down V-shaped thing. It's the power button. So you hit that. All right, now, depending on your calculator, it may actually create a power thing for you. Some calculators, I don't know if I have another one or not around here. Let me see if I have one. That one doesn't work, so I'm not sure. Give me one second. I'm going to move the camera briefly and see if I can find another one that's got a slightly different version that some of you might have. That one's got the same. So if I can't find it here in just a second, I won't worry about it. But some of yours is going to look a little bit different, is what I want you to understand. Most of the ones I'm grabbing right now are newer ones, so they have the newer version of the things. So, all right, here's an old one. This is a very old calculator, and some of you will have this type of calculator as well. So I want you to see both of these. Okay, so if that's the case, that you have an older version, maybe a TI-83. This is actually a TI-86. They're a little bit old, but if you type in the 10 here, same thing. You still have the same exact button here, the power button. But when you hit this power button, it just does that upside down V thing. But you can put the 3 there. Okay. On the one I had, we put the 3 there. Okay. So you can kind of see the difference between the two. Okay. All right. If you hit enter though, all right, that gives you 1,000. Hit enter here, that gives you 1,000. They give you the same answer. Okay. So once you just realize it can be written 2 different ways. The newer ones have the kind of correct looking version with the 3 actually up in a power. The old ones, it looks like that. Same exact idea though, you get the same number. All right, so 10 cubed is just 1,000. All right, so come back to our paper here. We're gonna put 1,000, so 4 pi 1,000 over 3. Okay, 4 times 1,000 is 4,000. Don't forget pi. I get a lot of people who forget pi along the way on these. Divided by 3. We reduce this if we can. This cannot be reduced on this one. So I don't want a decimal. So if you go to your calculator and you do something like this, 4,000 divided by 3, and you get this decimal answer, and then you put that with a pi after it, I'm going to count it wrong. I don't want that. All right. Now we could technically type all of this into our calculator and get a decimal answer, 4,000 second pi. If you remember how to do that, you hit the second button, and then pi is right here. Okay. So you hit the kind of top, the second version of that power button we just used, and then divided by 3. And I hit the wrong thing. Hold on. Divided by 3. Okay. We get that. Now, unless I tell you to give me a decimal, I do not want you to give me a decimal answer. I want you to leave it as 4,000 pi over 3. Okay, if I tell you to give me a decimal answer, then yes, 4,188.79. Okay, label, volume is cubed. That was inches, so this would be inches cubed. All right, and that's it. Really, really simple formulas. Let's do another really quick example of that. And then I'll kind of show you how to do this stuff in reverse, where I give you the surface area or I give you the volume, and you have to find the radius. So surface area and volume. Let's do this one. So make this a tiny bit harder by giving you the diameter instead. All right, so let's say that is 24 feet. Okay. So surface area, let's go to our formula again. Surface area equals 4 pi r. R in this case is not 24. R is 12. So 4 pi 12 squared. 12 squared is 144. 4 times 144 is 576 pi. Label feet squared. Very, very, very simple. All right, volume. 4 pi 12 cubed over 3. All right, 12 cubed, 12 times 12, 144 times another 12, 1,728 over 3. I'm going to double check that just to make sure I didn't make a careless mistake. Yep, 1,728 over 3. Now, 4 times 1728, I think that's 6912, if I did that math correctly in my head. So 69, see if I can write this correctly, 12. Don't forget pi over 3. I'm going to double check that again. 4 times 1728 on my calculator. Yep, 6912 pi. All right, lastly, reduce if possible. 3 goes into this 2, and then 3, and then 0, carry the 1. Yep, 2,304 times. Don't forget pi. Don't put this over 3 again. All right, we already divided it by 3. Remember, if this doesn't divide evenly, don't give me a decimal. 2304 pi, label, feet cubed. That is it. That's how these formulas work. They are not complicated at all. Now, what I do want to do next is give you the surface area and have you find the radius. Give you the volume and have you find the radius. Okay, so that's a little more complicated. So, if the surface area equals, let's say it's like 800 pi centimeters squared, find R. Okay, so we just set up our formula and we find R. So 4 pi R squared, that's our formula, and we were told it equals 800 pi. Now, I get some of you want to take a square root right away. You can't do that. You've got to get rid of this 4 and pi first. You can get rid of them in one step, or you can get rid of them in 2 separate steps if you want. Either way is fine. I'm going to get rid of them in one step. So I'm going to divide by 4 pi. Pi is just a number, so we can divide, multiply, and so on, just like usual. We're going to divide by 4 pi here. The pi's cancel and the 4's cancel. The pi's cancel. 800 divided by 4 is 200, so R squared equals 200. This is pretty simple now. We take the square root of both sides. Now the square root of 200 is a decimal. If we go to our calculator, it's going to say something like 14.14 or something like that, and a bunch of other decimals. I don't want a decimal answer. So we're going to break it down. 100 times 2. 10 times 10. If you want to keep breaking the tens down, you can, but remember, we're just looking for pairs. So I found a pair. Pairs go outside, so R equals 10. Singles stay inside. If you kept breaking it down, you'd have a pair of 2's and a pair of 5's. Remember, we multiply them back together anyways, so that's going to give me that 10. Label, centimeters squared was the area, so the radius is not squared, but it would be the centimeters. Okay? Let's do a volume one. Okay, volume. If the volume equals, I want to try to make this not overly complicated. So, and then I'm also going to show you how to use your calculator on a new button you might not have used much on your calculator before. All right, but let me come up with one that's not going to be overly complicated. So give me a second here while I think of one. All right, so if the volume equals 972 pi inches cubed, okay, we're going to find R. All right, so remember my formula, 4 pi R cubed over 3. And we are told that that has to equal this 972 pi, which I can put over 1. Remember, anytime I have a fraction, like fraction equals fraction, makes it really easy to do. So we're just going to cross multiply. Okay, so 3 times 972 gives me 2,916. 4 pi r cubed times 1 doesn't change anything, so 4 pi r cubed equals 2,916 pi. We are then going to divide by 4 pi, just like we did on the previous one. So those cancel. We come over here and we divide by 4 pi. Those cancel. If we divide this, 2,916 divided by 4, we get 729. So r cubed equals 729. Now, the next thing is something you may or may not have done in the past, or you may have done it and you forgot about it. So to get rid of a squared, remember we use a square root. So to get rid of a cubed, we use what is called a cube root. It looks like this, but we tuck a little 3 right in there. Okay, I'm going to zoom in on that so you can see that a little bit better. Let's see if I can get, no, I always go the wrong way on that, it seems. Okay, so we put a little 3 right up in here. All right, we don't do it like this, where the 3 is out front. That looks more like 3 times a square root. Okay, we tuck the little 3 right up in there. We do it to both sides, just like we did before with square roots. So we tuck the little 3 right up in there. Okay, the cube root and the cube cancel each other out, just like a square root and a squared cancel each other out. So we just have r. Now the cube root of 729, you probably don't have that memorized at this point, so I'm going to show you how to type it into your calculator. Okay, so let me zoom out just a tiny bit, and I'm going to show you how to type the cube root of 729 into your calculator. So on your calculator, all right, you have a cube root button. Okay, if you see this square root button, okay, you can't use that. Okay, but right here under this math button, so if we hit the math button, we get a menu here, and you look down, and right there, see how that has a cube root? Okay, the 3 is tucked up. It's not as big as the root itself. So that's what we want. So number 4. So you can either scroll down to number 4 and hit enter, or you can just hit the number 4. All right, so if you just see I just push the number 4, it automatically puts that cube root there. Okay, now that cube root, remember we were looking for was the cube root of 729. So now I just type in 729. And I hit enter. It gives me 9. So R equals 9. If it was inches cubed up here for volume, it's just inches for the radius. Okay? Now, sometimes when you type this in, you'll get a decimal. There are ways to break cube roots down, just like we break square roots down. I'm not going to teach that to you this year. All right, I'm going to let your Algebra 2 teach that to you probably next year. Okay? I'm going to look on the other older calculator and see if I don't see. This one's so old it doesn't even have a math menu. All right, so I'm not going to worry about that on the older calculator. It's going to be very, very similar, even if you have like a TI-83. Okay, that part doesn't change much. All right, I want to do something a little bit different. I want to kind of mix the two together. So, and then I'm going to do maybe one more example of each of just finding the radius real quick. Okay, so if the surface area equals, let's go with 256 pi square feet, then find the volume. Okay, so what we're going to do is we're going to take our surface area, we're going to kind of work backwards like we just did to find the radius, and then we're going to use the radius to find the volume. So it's kind of a two-step process. So we know our formula for surface area is 4 pi r squared, and we were told it equals 256 pi. So what do we do first? We divide by 4 pi. Pi's cancel, 4's cancel, pi's cancel, reduce. We get 64. Square root on both sides. R equals 8. It would be feet. Now we were told to find the volume. So now we're going to come over to our volume formula. Volume equals 4 pi 8 cubed over 3. 8 cubed on your calculator, 8 times 8, 64 times another 8, 512. So 4 pi 512 over 3. 4 times 512, 2048 pi over 3. If we try to divide that, it's not going to divide evenly. I don't want you to give me a decimal answer, so we just put feet cubed, and that would be our volume. So if the surface area is this, I can get to the radius and then reinsert basically my radius into my volume formula and come up with an answer. Okay? All right, we're going to do two last examples real quick. And the reason I want to do these two last examples is on that cube one, I want to show you what happens if you get a decimal answer. So we're going to do one for surface area and one for volume real quick. So if the surface area equals, let's come up with a number, how about 900 pi centimeters squared. I want you to find R. Okay, pause the video. Okay, go ahead and try to find R, all right, on your own, and then come back and check to see if your answer makes sense or not. All right, once again, you should have paused the video. You should have tried to find R on your own. I'll tell you, I know some of you don't do it. Some of you get lazy. You just want me to do all the work for you. Doesn't work well in the long run for you though that way. 4 pi r squared equals 900 pi. We divide by 4 pi, cancel, cancel. Pi's cancel, reduce to 225. Square root on both sides. R equals 15 centimeters. That one worked out pretty well. We didn't have to break it down at all like the previous one. Okay, let's do volume. If the volume equals, let's come up with a number here. And I'm going to include pi on it. There are times where we could even not include pi and make it really complicated. I'm not going to do that to you for right now. Okay, maybe we'd do that one like that in class or something. Okay, all right, so if the volume equals, let's go with like 800 pi. And let's go with inches cubed. Okay, we're going to find R. All right, so we set up our formula. Volume equals 4 pi r cubed over 3. We are told that that equals 800 pi. We're going to put that over 1 so that we can cross multiply. 4 pi r cubed times 1 is just 4 pi r cubed. 800 times 3 is 2400. Don't forget about pi. We divide by the 4 pi. 2400 divided by 4 is 600, so r cubed equals 600. Now, even if we weren't able to reduce this, we could still do the next step. Let's say that this was, you know, I'm trying to think of a number that wouldn't reduce well. Maybe I gave you 650 pi. Well, 650 over 4, or when you cross multiply, you get 1950 over 4, all right, and do the division. You could reduce that a little bit to 975 over 2. It's okay to have a fraction right here. I'll show you right here. Okay, I'll show you how to do that on your calculator real quick too. Okay, but we do the cube root. Remember how we write that cube root? All right, little 3 tucked up into that root. Okay, the cube root and the cube cancel, so that's r. Now I go back to my calculator, and I'm going to type in the cube root of 600. So remember, I go to math, okay, that math button right there. Number 4 is the cube root, and it asks for the cube root of 600. So I type in 600, I hit enter, and I want you to round to 2 decimals unless I tell you otherwise, so 8.43. Label. Since this was inches cubed up here, it's just going to be inches for the radius down here. Okay? Now, what I was saying about this, if I gave you something where this, after you tried to reduce it, was still a fraction, it's fine. It's not a big deal. Let me show you how that works. So, we'd still hit our math button. All right, we still go down to number 4, hit number 4. If you want to go down to number 4, then you just hit enter. It gives you the same exact idea. You can put a fraction in here. So if you had to take the cube root of 975 over 2, you just type in 975 over, you can use the division sign for over 2. And you just hit enter. Now if you have an older calculator, you may need to put 975 over 2 in parentheses. Okay? Depending on how old your calculator is, you may. So sometimes what will happen is you hit the math menu, go to number 4, you type in that 975, and on the older ones, it'll look more like this, and when you hit the divided by 2, you can see how that's not under the root now. Hopefully you can see the big difference between those two things. Okay, one of them has the fraction, the whole fraction under the root, one does not, and I want you to see that they're very different answers. Okay, so if you're doing a fraction under a root, you got to make sure it looks like this, and if necessary, use parentheses around the 975 over 2. Okay, so we don't want you to get the wrong answer on something like that. Okay, that's it for surface area and volume of spheres. 2 formulas, got to be able to use them forward, got to be able to use them backwards. So if you need to look at those formulas again, I'm going to put them here one more time. Surface area 4 pi r squared, volume 4/3 pi r cubed, or 4 pi r cubed over 3. I usually like the second one just because it makes it easier to cross multiply things. All right, and that's it for spheres.